So welcome to the 6th virtual office hours for the 2014 POSA MOOC. What we'll be doing today is going over my solution to the programming assignment for week 5, assignment number 4. We'll also answer any questions people have about the way to evaluate week 5, assignment 4. And of course, we'll talk about the next programming assignment, which is week 6, assignment 5. And I'll also answer any questions that you might have from the virtual office hours, and then of course any questions that you ask here live. So let's go ahead and get started. Let me bring up my Emacs window, if it's still around. So here's the version that you should have. The version you should have should be taking 2 parameters. One of them is the object, which in this particular case is going to be a text view, and the other case was the activity. And again, there's lots and lots of different ways to do this. This was an early version of doing this. And we moved away from doing it this way because there was a memory leak that was caused, or there was a, not a memory leak, there was a dependency on the text view. So we've refactored it in the other version I just showed you. So here's the way you would do this one. You would come in here and say something like this: activity equal mActivity dot get. So now we've got that activity, and if that activity is not null, then we would go ahead and do this. So if the activity is not null, we would say activity, run on the UI thread, please. And you can see here that that goes ahead and appends the result to the mTextView output. Now, there's been a lot of discussion on the discussion forum about whether this could still end up throwing a null exception. And I think the way, this is an area that's shrouded in mystery and confusion, but if you're absolutely very, very paranoid, you probably want to also deal with null exceptions here. And the reason for this is, even though we have ourselves a reference to the activity, because of the way that Android works, it's possible, at least in theory, for the activity to be deleted out from underneath us in this particular case. So in that particular situation, you should also then use a try-catch block and check to make sure that you have caught the exception. Now, what the heck you're going to do if this happens, about the best thing you can do in this case is log the fact that you had an error. You're not going to be able to get back to that activity. You're not going to be able to do the runnable. So that's how you do print with this other version. Here's the other way of doing done. As you can see here, basically the same basic idea, except this is a more interesting situation. So you can see here, this was the original way I had done the done method for the Android platform strategy. I went ahead and checked to see if the activity was null, and if it was null, I went ahead and stuck it at the end of the UI thread's looper, in its message queue rather, and when that guy ran, it was the last thing that got run from that thread, and it went ahead and did the countdown latch. So if you're going to do this, you probably want to say something like this, else you want to say mlatch countdown. So that's yet another way to do it. And what this is doing is, if it's not able to get access to the activity, it's going to go ahead and try to do the countdown latch. Now that, of course, may not be useful anymore because the activity may have gone away, in which case we're just being very, very comprehensive in our handling of the situation. So that's one way to do it. I showed you another way to do it, which is to say, the heck with all this. Let's make our lives a lot easier. Let's just go ahead and call countdown latch directly like that. And that will also work. Both of those things work. The reason I'd done it this way originally was I was trying to ensure that the countdown latch was the last thing that got done when we were dealing with a queue of threads. But your program should work either way. Whoops. Yes, it's you're right. It's not 0. It's null. I've been doing too much C++ programming. Let me go back and fix that, because that's 0. That's funny. Null. How about that? That maybe looks better. All right. So the question: why do we use the output text interface implementation? The reason for doing that was to avoid the whole issue of having, we needed to be able to have a weak reference to something that would allow us to be able to avoid the leaks or the problems with garbage collection that would otherwise occur if we passed in a text view object directly. And so what we did here was we basically made there be just one weak reference. Let me go ahead and bring that back up again, and I'll show you. In the later solution, which is, by the way, not the one that we're actually evaluating. This is one that Mike and I came up with later. We ended up using a weak reference to something called output text view interface, and output text view interface gives us back a reference to a text view and a reference to the activity in the implementation. And that way we only have one thing that we're keeping a weak reference to. So it was just a more comprehensive design that did a more effective job of avoiding problems. Okay, yes, exactly. The point was office hours are much better than posting solutions because then you have to actually think about them. That's exactly the motivation. All of my students ran mlatch countdown on the UI thread. That's probably perfectly fine in this case. So I think we're okay. Let's see. Activity get self is null for me. That's probably because that was not the version that we pushed out to the website. That was the version that we came up with later. How will this last hour change affect the grading? Don't grade to the version I showed you first. Grade to the version I showed you second. And the second one I was just showing you was one we came up with later. And I wanted to show you how to address the issues caused by the original version that had two parameters, one of which was not dealt with as a weak reference. Okay, what I'd like to do now, if there aren't any other questions, is I would like to go ahead, any other questions about this other assignment, or the one we're just completing. Let me go ahead and show you the next assignment. Oh yeah, there's a question about the GeoNames application. Sure, please go ahead and ask any question you'd like about the GeoNames application. While you're doing that, I will go ahead and bring up the bring up my Emacs window, and I can show you a couple different things while we're doing that. So if you have a question about the GeoNames application, don't hesitate to ask it. Otherwise, what I will do is move over to the other directory, and we'll talk about the next programming assignment. All right, so this is under assignments, week 6, assignment number 5, and there we go. So there it is. These are the classes involved. This particular assignment, for my money, is a lot more interesting than the ones that we've done so far, and that's because it's really starting to get into the more powerful parts of Android and Android services and concurrency run with services. If you recall, last time we had discussed this topic. Someone had asked a good question: what's the reason why you would use an activity versus, or sorry, use an async task versus using a service? And they're both useful, and you can use them often for much the same thing. The main reason you would use a service versus an async task is if you wanted to be able to make something that could be used by other applications, or would just have more properties of being able to kind of run in the background and be decoupled from the activity and the UI thread. Okay, so let's take a look at this, and I'll come back and take a look in the. Oh wait, there are a few more questions. Let me get to these questions while people's minds are fresh. So within the done method, why do we have to use another runnable? Well, as I just got done explaining, you don't have to use another runnable. That's one way to do it. The reason for using another runnable is to make sure that releasing the latch, or reducing the countdown latch by 1, is the last thing that happens in that particular processing sequence. If you don't do that, then you're releasing the latch, but there's still a whole pile of things in the queue that need to be processed. So if you really think about this from a strict barrier synchronization point of view, you might not want the play ping pong object to return until all of the processing is finished. I guess one way to look at this, to use a metaphor, if you're in a swim meet with a relay, it's certainly possible for the next swimmer in the heat to jump off the wall before the other person touches the wall, but but the rules are that you're not supposed to jump until the person touches. So you can kind of think about that in terms of the things that are queued up. We really don't want to continue on until all of those requests have been processed. But it works the other way, so you can go ahead and grade them either way you'd like. Is the null check required on activity? You really should be checking to see if activity is null, and or checking to see if the null pointer exception is raised. If somebody doesn't do that, then I wouldn't necessarily take points away, but it's probably a good idea to leave comments in the comment field to remind them that they should do that. And the reason they should do that is it's possible that the activity has gone away, and so you need to be able to guard against that. Judy said, I was lost in the print explanation. So just don't, if you got lost in the print explanation for the first example, ignore that example and look at the second example that I used, which is the one that's based on the shell that you've got. Let's see. It feels strange to use weak reference, essentially saying we might not need this field and it's okay to garbage collect it. But we know that we'll definitely be using that field later. Shouldn't garbage collection be able to manage on its own without leaks? So the question that you're asking, Dell, is a very profound Java question that is part of the issue of Java and Java garbage collection. And it has to do ultimately here with circular dependencies. And this gets exacerbated, or it gets raised to a higher level of prominence in Android because of the fact that you've got these different things like handlers, which can run in the background in a separate thread and then be able to make calls back to activity objects that occur in the user interface thread via the run on UI thread method or other methods that work like that. So as a result, you've got circular dependencies. The activity contains reference to a reply handler or some type of handler, and the handler has some kind of reference to the activity. And if you don't use a weak reference, then you've got a circular dependency, and garbage collection will be precluded. So we need to find some way to break that dependency. So the way that you do that in Java is by using a weak reference. So that's what we're doing. But once you've got a weak reference, then you've got the issue that what if the thing that you're referencing via the weak reference goes away while the thing that's being referenced is still alive? For example, it might be in its own thread, which doesn't get shut down automatically when its enclosing activity is garbage collected. So what you're really dealing with here are a lot of really, really subtle interactions between concurrency and memory management, garbage collection, encapsulation, and so on and so forth. And so this just gets raised to a higher level of importance in Android because of the way its handlers work and other things work. So this has always been an issue in Java. And you might want to take a look at a bunch of links that are available both in the slides that I've been presenting as well as on the discussion forum, and you'll get a chance to read in more detail about why this is such an important issue. It's also something that's very difficult to find a definitive set of issues and written up in pattern form. Somebody needs to write up a pattern language for dealing with this stuff. Pedro asked a question that I've answered a couple times already. You don't have to take points off if null references are not checked, but please leave a comment explaining why it's important to check them. Is the following implementation of print correct? Get the UI handler with looper, get main looper, and post a runnable to that handler. Yeah, you could probably do that. That would be awkward. If it works, it's fine, but I sure as heck would not want to maintain that code, but as long as it works, we should be okay. My assignment hasn't been processed. Will I get 0 points now? Sheila, I'm not quite sure which assignment you're talking about. Is it the one that was due on Monday or some other one? Why don't you post a message to the virtual office hours discussion forum if I don't answer your question here, and I'll try to make sure we understand what we're doing. Some solutions don't have the method platform name. Yeah, that people probably were using an earlier version of the shells, not the one that is the official version. There's a whole long discussion about the official version versus the unofficial version. Be kind to people who don't use the official version, but at this point, people really ought to know after almost 8 weeks of the class the difference between the official version and the earlier versions, but I realize that doesn't always happen. Is it okay to leave the catch statement empty? Well, if there's something else, we probably should do some logging in that situation or something to make sure that we indicate things have gone wrong. Okay, let me go ahead now and move over. I think I answered all the questions that came up. So let me now move over here, and we're going to talk about the next programming assignment, which, as I mentioned before, is a lot more interesting. So let's take a look at it. So as you can see, this next assignment has a couple of parts to it. It has an activity, and it has a couple of different services. Now, the activity has a base class, and we'll come back and talk about that in a second, and the services and the activity all share some common code, which is called download utils. And it also has a little bit of magic in here in case you're in an environment that does not have available access to the network or good access to the network. Either the cases is an issue. You can go ahead and just download things, quote download things from a local asset, or you can go ahead and use the internet. So by default, we use the offline version because we didn't want to assume everybody had their network up and running. But if you want to make this work for real, go ahead and turn this to false. So that's important. So let's go ahead and start with the activity first. So here's the activity. This example also heavily uses patterns. It describes the roles the various elements in the solution play in terms of the different patterns. Always more than happy to talk about those things. I think that's a lot of fun. We really tried to document this extensively so you could look at it as a reference. So here's the download activity, which extends download base. And we used download base because we wanted to separate out the stuff that related to the user interface operations from the things related to communication operations. There's no particular reason you have to do it this way, by the way. It's perfectly acceptable to not do that. It's just the way that we did it. So let's go ahead, just for fun, let's go ahead and take a look at download base first. So download base does a couple things we almost always do. It starts by grabbing a tag that we're going to use for logging, which uses the simple name for the class, or you can also use the canonical name, either one. We have a couple of various UI components for edit text, where you can put the URL that you want to download. And we have an image view that will be used to fit to basically display the image. And then we also have a bitmap, which we use for resetting the image when we're done, if we want to reset it. And then we also have a current bitmap, which we use for testing purposes. So here's the code that actually does the display bitmap. You can see here it basically takes a path name that it gets back from the service, and it goes ahead and decodes the file using a bitmap factory. It gets a bitmap, and then it goes ahead and makes that bitmap what gets displayed in the image view. So that's pretty straightforward. Here's the get URL string method. This is just a helper method that takes what the user has given and returns it. By the way, someone asked a really good question today. You know, in a lot of the example code I'm writing, I'm kind of being a little bit more concise than I probably should be. I should probably, if I was writing production code, I probably should be checking after every time I extract some intermediate element to see whether that worked or not, and then either logging the errors or throwing an exception or something. Because this is a class and not production software, and I have to be able to fit things onto slides, and I have to be able to explain them without spending 80% of the time going through error handling use cases, I sometimes am a little bit more careless than I might be if I was writing production code. So, you know, obviously make sure that in your real code you do a more effective job than I am of error checking and logging. But you know, the goal of the class is not to teach you every last aspect of production software development for Android. It's to focus on concurrency and communication. But I'm just mentioning that so people don't get confused in practice. Here's reset image, which resets things to the default bitmap. Here's the onCreate hook method. As you can see here, it goes ahead and grabs the content view, which lays out the default screen, and then it goes ahead and grabs a couple of different UI elements for the edit text and image view, and a few other things. So that's kind of all the user interface stuff. Download activity is much more interesting in my mind because that's the part that's fun for me, the communication and concurrency stuff. So it's got a couple pieces. It's got something called a message handler, and we make this static to avoid this whole issue about strongly coupled circular references, and then we make a weak reference to the enclosing class. This is a pattern that you see commonly used, and there's a whole discussion here. If you want to read more about this, go see this link. It'll give you more information about why we're doing this. Here's the constructor, which basically goes ahead and makes a weak reference from the download activity. Here is the handle message method. This method is going to be called back in the, I think it'll be called back in the main thread of control, just because of the way this happens to work. But it could, of course, be processed in a separate thread if we set things up slightly differently. And what this guy does when he gets called back, he's going to take the result that came back from the service, and he's going to go ahead and do something. And then, of course, that something is pretty easy if you read the code a little bit. It's basically going to extract out the path name that came back from the service and call another helper method to display that path name. So that's the code that you have to write. And it's basically sort of a one-liner here, and you can kind of use the utilities to shield yourself from a lot of the details of how that works. Here's the message handler itself. We can initialize this in a couple different places. I've initialized it here as a member variable initialization, but there's no reason I couldn't have put this into the onCreate method. It basically works essentially the same. And notice it's passing in this, which of course is the outer classes, the activities, so they can be used as a weak reference inside the handler. Run service is the method that gets called back when the user clicks a button, and it figures out which button was clicked. If it's the intent service button, then you're going to go ahead and make an intent that's corresponding to the intent service, and then you're going to go ahead and start up the intent service, the download intent service, and then likewise here, if you do the thread pool solution, it's going to get an intent from the thread pool download service, and it's going to go ahead and start that guy. I think there should be download intent service right there. And in either case, it goes ahead and pops up a toast and says what happened. So it'll tell you that it's downloading. And of course, especially if you download stuff that's already on your machine, on your device, the solution, the image will probably come up faster than the toast will. If you download something over the internet, chances are you might actually get the toast before the image shows up. Okay, so that's basically the activity. As you can see, there's not a heck of a lot going on here. We're basically invoking a service, giving it some information, and then that is going to do the work, and it's going to give us back the path name, and that path name is going to come back as a message that comes back to the handle message method. Now, this sort of begs the question, how do we figure out what methods to call? Well, we made life a heck of a lot easier for you by writing a file called download utils. Originally, we were going to have the people in the class fill in the download utils methods, at least some of them, but we decided ultimately to fill them in. If you want more of a challenge, try to write these things without using download utils, just for fun, and you'll see how it all works. All right, so here is the implementation of make messenger intent, and this is going to be used to make the appropriate type of intent, and you will see how that works in a second. This is sort of a helper method that gets used both by the download intent service and by the thread pool download service, and it even uses a little parameterization for the class, which gets passed in here as a template parameter or generic parameter. And you can see here it makes a new handler with the handler that's passed in. It makes a new intent, and it puts the messenger that you made into the intent, and then it goes ahead and it puts the URI into the intent. So it's basically a factory method that's used to make an intent that'll get given back to the activity. Notice, by the way, that this method call is actually a local call. When the activity ends up invoking this, and I'll show you how it gets invoked in a second, this call is done in the context of the activity. It is not a remote procedure call. So it's a factory method. Here's the send path method. Send path takes the path name to the file, and it creates a message which has a bundle in it, and it puts the output path in the message as a string, and it sets that bundle as the data of the message, and then it goes ahead and it sends that message back to the client activity. And of course, that messenger would have been created in the context of the activity. And it would have been created in the context of the activity by this call up here called make messenger intent, which would have made the messenger in the first place. So that's how send path works. Download and respond. Originally, it had a cryptic comment in there that was left over from an earlier version of the assignment where we had people filling this in, but we took out that and we just gave the solution, and I removed the comment. So if that confuses you, just ignore that hint that used to be there. Download and respond, as you can see what it does here, it basically goes ahead and downloads the file, and then it goes ahead and sends the result, which is the path name, back to the activity via the messenger. So that's what download and respond does. And here's download file. As you can see, download file works differently if you're offline versus if you're online. If you're offline, it goes ahead and grabs the resource from the resources information that's stored along with the application. That's kind of a boring example, but we just use that in case you don't have a good network. The more interesting one is this one, where we make a temporary file name, and I'll look at that code in a second. And then we go ahead and we create a input stream that's going to be connected to the content we download across the internet using the url.getContent method. And we grab that guy, and then we go ahead and create an output file stream, which is the temporary file connected to the temporary file, and we copy the input to the output. And when we're done, we return the path name to the file. And here's how we make the temporary file. In this particular case, we always put the file in the same place every time. In real life, you probably wouldn't want to do that. You'd probably want to make a separate file name for each one. And so this is showing you some code you could use if you wanted to do that, which illustrates the use of adding a timestamp to make each temporary file unique. So that's just illustrating how you could do that. And here's the copy method. Nothing exciting, just copying from the input stream to the output stream, which connects you with the results coming back from the web into our file that we're storing the results into. Okay, so that's download utils. Now let's go take a look at intent service. Intent service is really, really, really simple. Using intent service is just remarkably easy. If you watch the videos, you'll see that the intent service is used to run one request at a time in a background thread. So it's concurrent with respect to other things that are going on in the activity or the service, but there's only one thing going on concurrently at a time using an intent service. This is a great example, by the way, of the command processor pattern, and we'll talk more about that later. So download intent service is an intent service, and it has a couple of constructors that initialize a couple things, and then it has a method called make intent, and make intent is just a factory method, and you can imagine it's going to use the make messenger intent helper method that's in download utils and just return the intent. You fill that part in. And then onHandle intent, onHandle intent is the hook method in the template method pattern that gets called back. And this guy always runs in a separate thread of control. And if you want to see exactly how this works, go watch the video on Android Intent Service, which walks through the code line by line, or at least the most important parts of the code line by line, and shows how it all works. This runs in the background in a thread. And what it'll do, of course, here is it'll go ahead and it'll download the file, and it will reply with the messenger. So that'll all go right there. And you can use the helper methods that are in download utils to shield you from all the details of how that works. A couple of things. There's been some really good questions people have been asking on the forum about whether or not services that run in a separate process need to run in a separate thread. So here's the way to look at this. So you'll notice that this is a generic framework for processing requests in a background thread. The intent service is a generic framework that implements the template method pattern and the command processor pattern and so on and so forth. And when you use an intent service, as we are doing here, you do not know, as the author of intent service or even the author of download intent service, whether or not this thing is going to run in a separate process or not, because that's a late binding decision that's controlled by the configuration attribute that's set in the Android manifest file. So if this ends up running in the same address space as the activity, then this really has to run in the background thread. Otherwise, we'll get the dreaded application not responding exception thrown to the activity. If this runs in a separate process, then if you do a few magic things, you probably can reuse the main thread of that process without having to spawn a separate thread. But the writer of intent service doesn't know that that's what you're doing. So it has to be able to behave the same regardless of whether it's co-located in the same process as the activity or run in a separate process based on the settings of the attribute in the Android manifest file. So to be on the safe side, it works the same way in both cases. It always spawns a background thread using the examples that we show in the video, even though that isn't always strictly necessary if you run in a separate process. If you do run in a separate process, though, you'll have to do some additional things to avoid similar problems with the timeouts occurring in that service process. So a good rule of thumb is don't beat yourself up trying to get too clever by having the assumption your services run in background processes and hijack their main thread. Just do something like we're showing here with intent service or some other mechanism, and then your code will always work properly irrespective of which context you run it. So that's the intent service. Remember, with the intent service, when all incoming intents have been processed, then the service automatically shuts itself down. So it's basically a started service that's kind of a one-shot service, even though there actually may be multiple requests that show up, depending on how fast they arrive from client activities. Our particular example here wouldn't really exercise this because we just do one thing at a time, but we could write this in a loop and generate a bunch of requests, and things would happen, or we could have multiple clients all calling it simultaneously. All right, that's the download intent service. Let's now talk about the thread pool download service. The thread pool download service is not an intent service. It inherits from service directly. And what it does is it's going to spawn a pool of threads that will run as part of the executor service abstraction. And we're going to have 4 threads here. And we have an executor service object called mExecutor, and that is what you have to initialize. So you have to come into the onCreate method, and you have to go ahead and replace this null with something that will create the appropriate pool of threads. And if you look at the factory method in the executors class, or if you kind of do a sneak peek at some other examples that have been showing up lately in the examples directory, you'll see exactly how to do this. And it's really, really, really simple. Here is make intent. Make intent for the thread pool download service is almost identical to make intent for the download intent service. The only difference being, of course, that the solution here will pass in a different class than for download intent service. So you have to fill that in, making the appropriate call to make a messenger intent. On start command is where all the magic happens. Remember, on start command, well, on create is called only once when the when the service is first started. On start command is called every time a new intent shows up from a client. Remember, the client could be an activity, it could be another service, it could be whatever. So what we're going to do here is we're going to go ahead and create a runnable by replacing the null with a runnable, a new runnable. And that runnable is basically going to be a closure, or a command is perhaps a better way to put it. And that command is going to be inserted into the executor. And one of the threads in the thread pool in the executor will take that command and will run it. And of course, that command is going to essentially download and respond. So it's pretty obvious, hopefully, what it does. Now, a lot of interesting things to talk about here. One of the key things to note is that this service does not terminate itself, unlike the intent service. The intent service, after the requests show up, it shuts itself down. This service does not shut itself down. Now, we could define some way to shut itself down. After 10 minutes of inactivity, it could shut itself down via timer control. You could have another monitor service that monitors this service and then shuts it down if it doesn't get any activity after a certain amount of time, et cetera, et cetera, et cetera. But the main thing I wanted to show here was the ability to start a so-called standing service, which runs for an extended period of time and provides a pool of threads that can be used to process multiple requests from the same client or from multiple clients concurrently in a pool of threads. The current client doesn't really exercise this, although it's not hard to extend it to do that by simply running start service in a loop and passing a bunch of things in, and then you would actually see this thing processing stuff in multiple threads in the pool. Okay, so that's basically what you have to do. Those are the main things you have to fill in, and I think I've covered everything that was part of the shells. So you have to fill in a couple things in download activity. You have to fill in a couple things in download intent service. You have to fill in a couple things in thread pool download service. And as usual, take a look, read the comments, try to understand the patterns, try to understand how the things are working. And this, of course, is also an example of two-way communication between an activity and a started service using a messenger. And just as a little hint, the next set of videos we're putting out in a couple days actually will show how to use bound services to communicate using messengers and or aidl. So those things will be appearing shortly. Some of them are actually already up on my YouTube channel. Okay, so now we're back, and I will go ahead and answer questions that people have asked. Let's see. Comments in the assignment, very helpful. Yes, I think the comments are great. This assignment was largely done by Mitchell Gordon, who's one of the students who's helping out this summer, and he's done a fantastic job of documenting everything and picking everything up. Mitchell basically learned Android in about a week, and so he picks this stuff up very, very fast, and he went through all the videos in about 3 days, and then wrote solutions to a bunch of assignments. So I'm very happy how quickly he picked it all up, and he also has a good handle on the patterns as well. Let's see. Connected to a different URL than the pre-configured one, it was a lot quicker. Do you have a bad connection, or was it overloaded or something? Well, the connection, I think by default it goes to a cloud server in the Coursera cloud. So who knows whether that's fast or slow. But one of the things, Sheila, that you come away with hopefully from that experience is that downloading content over the internet runs at variable amounts of time. And even if you're downloading a very small image, such as the ones that we use here, it can still take a fair amount of time, which is why we want to run these download operations in a separate thread, in a separate service with a separate thread, because they could take a long time to run, and we don't want to block the activity for that duration of time. Should we kill each service after its use? Well, Tom, so as we discussed, the intent service automatically shuts itself down. If you go and watch the Android intent service video, you'll see it shuts itself down. You can also write services that shut themselves down. The download application example that appears in some of the videos from last week illustrates how to do that. And as I showed you with the thread pool download service, that's one actually that you would have to either shut down separately by some other monitor activity or monitor service, or shut it down based on the passage of time, or after some period of inactivity you might want to shut it down. So those things are left as exercises for the reader to figure out what you'd like to do. But you do not have to kill the services. Do not worry about that for this particular assignment. What is a closure? Oh, great idea, great question. Let's go take a quick look at closure. If you take a look at the one of the videos, I think it's the video that talks about posting runnables using the Hammer framework. Let's go take a look. I'll go show you the video that I'm talking about here. Let me just make sure that this is showing up. Okay, good. So if you take a look back, I think it might be week 3, posting and processing runnables with Android Handler. If you download and watch that video, it explains to you what a closure is, and it shows you a link to a web page about closure. And here is that web page. So this web page talks about what a closure is in a generic sense. And then it also talks about what a closure is in the context of Java. And so as you can see here, they have these things called local classes, and you can name them or not, in which case if they're not named, they're called anonymous classes or anonymous inner classes. And so basically this explains how a closure works. And basically what a closure does is it captures some of the variables in its enclosing context and then passes them as a command to somebody else who will then turn around and process that command and access those variables. So there's lots of really nice examples that are described here that explain how closures are implemented in Java, and also how closures can be implemented in other languages beyond Java. And as I think you're seeing, they're starting to give lambda expressions in languages like C++. They're starting to get lambda expressions in Java. So we're starting to get better support for closures in these programming languages as they evolve. Let's see. Will the updated version be published? Harold, I'm not sure which updated version you're talking about. If you're talking about the week 5 assignment 4 version, I've been very reluctant to make changes to the skeletons once I've released them, even if we come up with better solutions to avoid confusing people. But we'll probably put those things out later once the class is over, and people will get the benefit of all the stuff sort of started from scratch with all the lessons we learned as the class went on. I saw you decrement the mlatch in the new runnable inside the print method. Can decrement be done in done and await also or instead? Yes, we talked about that already, Tim. You can decrement in a couple of different ways. If you go back and watch the video, I showed several different ways to do it. Aha, now we have a question about the GeoNames application. Let's go look at GeoNames so people will know what the question is. So I've been probably having way too much fun lately with various assignments that I came up with or examples that I came up with, some of which I'm filming for upcoming videos, some of which I was just having too much fun doing. So let's go ahead and kind of back out here, and we will go take a look at the GeoNames application. By the way, there's a new example that I'm going to be making a video about, probably starting later today, called the acronym application. And the acronym application is even way cooler than the GeoNames application in a lot of ways. But let's take a quick look at GeoNames. So here's GeoNames. GeoNames basically is an application that illustrates the use of bound services with aidl for both synchronous and asynchronous communication. And so the question that Chen asked is, the difference between async and sync is that async uses the callback. That is correct. And the callback has 2 different threads. That's correct. And the async sender and receiver are in different threads, but the methods are in the same class. So let's just kind of walk through this example. I was originally going to film this example, but then I decided not to. And the reason I decided not to was I wanted to show a better example of using aidl. And so we came up with another example, which is the example that's called acronym application. And Mike Walker did a great job of implementing the acronym application, and then I went through and kind of cleaned it up a little bit to make it look more like the other code that we've written. And so that's what I'm actually making the video about. So I'm not going to talk about the acronym activity and acronym service at the moment, because I'll make a video about it shortly that'll come out next week. But that one is way even more cool, as you'll see when we talk about it. But let's come back here and we'll go take a look at the GeoNames application. So by the way, the GeoNames application is actually based on something that Adam Porter showed in his class. He showed an example of this GeoNames application using an async task. So he has an example, I think it's called like networking URL. There's a networking URL example he showed in one of his networking videos, and he uses an async task. And I decided for fun I would go ahead and redo it using a bound service instead, just to illustrate the differences. So here's the key things to note. There's something that's called GeoNames call. And GeoNames call is a 2-way blocking aidl method. So get web services results takes the URI to the web service, and it gives you back a string containing the contents of the web service. So that's one thing. That's the synchronous version. Then there's also an asynchronous version called GeoNames request, which is a one-way call, not a two-way call, but a one-way call that takes the URI in, and it also gives a callback object. That's the callback object. The callback object has a one-way method called sendResults, and that's going to be used to send the results back to the activity that invoked it. So that's basically the idea. So we have a two-way call that's synchronous, and then two one-way calls which are asynchronous. So if you go look at the GeoNames activity, this basically sets everything up, and the video that's coming out will talk more about this. The videos that are coming out this week will talk about how the bound service protocols work, etc. If you go to my YouTube channel, you'll see the first video up there already. I just posted it yesterday. I have another one that I'll post later today, and then another one I'll probably post hopefully by Friday. And there's a whole little dance that goes on with these things when you start up. When you start up, when your activity is ready to become visible, a call is made to bind service, passing in the intent to the service, and something that's called a service connection. And we have two service connections, one to the async version, which is this one, and one to the sync version, which is that one. And both those connections get made, and what happens when a connection gets made is it goes over to the service and it calls its onBind hook method. And onBind then returns an object that implements the stub that's generated by the aidl interface. We'll talk more about that in a second. So onBind is a factory method that gives back a binder, and that binder then gets passed back to a service connection object via its onServiceConnected method. And as you can see here, we get the callback, we get a binder back, and then we basically cast this thing into an interface, which is essentially a proxy, to something that can do two-way calls and also something that can do a one-way call. So GeoNames call is a two-way call proxy. GeoNames request is the one-way call proxy. Okay, so far so good. That's how we get those things established. Then, when somebody actually clicks a button, what happens here is we go ahead and do the right thing. So in the case of the synchronous call, we do a two-way call, and this call will actually block right here until we're done. So the main thread of control is blocked, which of course is a problem. For the async version, however, it does an asynchronous one-way call passing in the callback object. And then of course it doesn't block, because that's a one-way call. It doesn't block. Here's the implementation of these guys. Let's look at the synchronous one first. It's very simple. All this guy does is he fills in the implementation of a stub, which is automatically generated for you by Android, and he fills in the get web services result call, which goes ahead and calls into the GeoNames utils helper class and calls the get web service results method. And we'll look at that in a second. And this call here, this call called get web services results, runs in a separate thread of control. So it runs in a pool of threads that are allocated by the Android binder. So that's the synchronous version. Here's the asynchronous version. The asynchronous version of this thing, as you can see, has a call web services method, which also runs in a separate thread of control. It runs in a thread in a pool, and it goes ahead and grabs the results from the web service, and then it calls a callback method called sendResults on the callback that was passed in. And that callback method is then dispatched here in the activity. And this is also run in a separate thread of control. So this does not run in the main thread. This runs in a pool of threads that are allocated inside of the process where the activity is running. And this guy's sendResults method will take the results, which are the web service results, and then it goes ahead and it creates a new runnable, runs it on the UI thread, and does a display results method call to do that. So that's basically how we kind of get information back and forth. Here is the actual web service interface. This is a very, very simple web service. Basically just goes ahead and takes the URL that you pass in, which in this case goes to the GeoNames service, which can do things like look up where earthquakes are or other geographic information, and it goes ahead and grabs the content, comes back as a HTTP URL connection, and then we take that HTTP URL connection, and we're going to go ahead and copy the input stream, which is the contents that come back. We're going to copy that into a string, as we show down here. We're going to copy this thing into a string, and then we're going to send the string back to the caller. Goes back as a string. And as you can see there, that's either going to return here as the return result from get web services results, or it's going to be called back as a one-way callback method called send results on the callback object. So Chen, hopefully that answered. That was probably more than you were looking for as far as how this all works. But since I'm not actually going to film this particular example, at least not at the moment, I wanted to kind of go through it. It's a really fun example, and it's very canonical. I think you could imagine doing a lot of things using this basic approach. In fact, if you really were so inclined, this example does not do this, but if you were so inclined, you could write a really nice service front end to a bunch of different web services that could kind of be used by multiple applications to access web service information. The acronym example we'll look at is kind of an example that works with the acronym expander service. Oh, here's a good question from Pedro. What are the major advantages in using the aidl services compared with the other service options? So if you're doing, I think this is actually talked about in the upcoming videos, so I'll give you a summary here, but this is actually covered in the videos that are coming out. So in a nutshell, aidl is very useful for two situations. Number one, when you're communicating complex data. So for example, when you look at the acronyms example, we're sending back a list view of acronym data objects. And doing that with messengers and so on would just be a real mess. What an awkward thing to have to do. So one thing is that aidl gives you a strong type system, and so you can deal with objects in a strongly typed way that looks a lot more like you're just writing regular object invocations as opposed to object invocations to things that may run in other processes. So that's one reason. The second reason is that aidl out of the box gives you the ability to have a pool of threads be used to process your requests. So you don't have to think too long and hard about how to do the processing. So as a result, thread pools are handled for you automatically. Now, there still are some subtleties in that context as well, but for simple applications, the ability to use a pool of threads is a nice, convenient thing, as long as you remember that calls to aidl operations will run in separate threads. So if they access shared state, you have to use synchronizers to shield concurrent race conditions and other scheduling hazards to that state. Is it bad practice to use the this keyword? Not quite sure, Jordy, what context you're asking. Are you asking about using this as a context, or are you asking about this in some other context, or are you just asking from the point of view of, should you prefix access to data members and methods with this? So try to ask the question a bit more specifically. Donald, you're a little confused about which solution. Use the second solution I showed as the one. In fact, I'll probably just edit the video when I make it, and I'll just show the one that's the actual solution that we use. So only grade to the one that matches the skeletons that we gave out as the official version. Hopefully that explains things. Yes, activity equals 0, right? Too much C++ programming, rot your brain. Get application versus this. Ah, yes. So Nicola, you've asked an excellent question. So should you be using this versus application context? Sometimes it matters, sometimes it doesn't. If you're trying to do stuff where you need to make sure that the lifetime of whatever you're doing is the broadest lifetime for an application, then you want to use the application context. Other situations, it doesn't really matter. For our simple examples here, it doesn't really matter. If you're writing other kind of examples, it would matter quite a bit. If you're trying to write generic services that are used to pass back elements or files to arbitrary applications, not the application where the service and the activity both are in the same application, then you have to use other mechanisms altogether besides get activity or get application context. In particular, there's various ways of being able to get parcelable data and parseable files and pass those back, and I'll post some examples to that later to the discussion forum. But this is one of the great mysteries of Android programming that isn't really documented clearly in any one place. Using aidl versus thread pool services with messengers and complex data types, which one has the best performance? Well, that's a great question. Under the hood, messengers and aidl use essentially the same mechanisms. Under the hood, they all use the binder framework, so they're using the same mechanisms for a communication point of view. The main difference is that with aidl, the aidl compiler is generating stubs for you automatically. Now, you can look at the code and see what it looks like, and in some cases you have to write your own variants of this to make your own data types that can be marshaled properly if aidl doesn't know how to do it directly based on the types it knows how to deal with. But I think they're probably pretty much identical in terms of performance. I haven't really seen a lot of effort in Android to optimize the generated stubs, so you're probably going to get more or less the same performance in both cases. It just matters whether you do it yourself or whether you have it done for you by the aidl compiler. I'd love to have somebody do some benchmarking to see which one runs faster, but I have a feeling that it's probably roughly the same. And under the hood, they're both using the binder framework to do the mechanisms. Chen asked the follow-up question: in the GeoNames application, aidl handles multi-threading automatically. It puts the callback in a different thread because I don't see a new thread created explicitly for the callback. That is absolutely correct. Like I said, when you use aidl, the methods that are invoked as callbacks run out of a pool of threads, and so you have to keep that in mind. And by the way, you have to be careful because that pool of threads is not infinite. So as a result, if you have lots and lots of requests, if you had a really high-end server, which might be a little strange on an Android device, but if you had a really high-end server with lots and lots of processing from lots of threads, you could run out of threads, and then you could end up with deadlock and other types of situations as well. So that's another consideration. When does the new thread start? The new thread is started when the program runs. So there's a pool of threads that are allocated or pre-allocated by the Android runtime, by the binder runtime. And I think if you take a look at the classic video from 2008 Google I/O, there's a nice discussion in there about how the binder framework works, and they show you kind of some nice diagrams. This is called The Anatomy and Physiology of Android, and I have a link to it in the POSA FAQ. And it basically talks about how this stuff works under the hood, and it shows a pool of threads. And if you look at the source code, you can see that they allocate a pool of threads. And I believe that those are pre-allocated, and they don't change. Once they've been allocated, they are not expanded or contracted, I believe. Now, things may have changed over time, but last time I looked into it, that's the way it worked. Why does a latch countdown need to be done in the UI thread? It doesn't need to be done in the UI thread. You can do it in the UI thread, but it doesn't need to be done in the UI thread. I can't run unique ID generator application. Logcat tells me it can't update an older version of the app. I'm not sure what the problem is. I will take a look and see what is going on there. I don't know what that would mean, though. Since the aidl has its own thread pool handling, how can you check and configure the settings of this thread pool? I don't think you can. You might be able to. There might be some options to be able to do that. That's something you should kind of dig around in the binder framework. There may be a way to configure that somehow via some kind of configuration options, but that's sort of below the level at which most application developers would work. The thread pool service must be stopped explicitly. Yes. Pedro, should we ignore this minor detail for the assignment? Yes, you should. You should not try to stop it. It's not meant to be stopped, so don't worry about it. Let's see. Derek is asking, is it okay to just call download and respond since it wraps up the calls to send path and download file? Yes, absolutely. That's why it's there. Why the try catch and print? Neil asked the question, why the try catch and print? That was basically, there's a long, interesting discussion taking place between TP and Kamal about garbage collection and so on. And I think the belt and suspenders way of dealing with things if you really, really, really want to guard yourself against all possible malfeasance that may occur, you should probably first grab the activity and stash it away in a local variable using the mActivityGet method to get the activity. And then you should go ahead and also do a try-catch, because if the activity were to disappear after you grabbed a reference to it, if it got killed for some reason, then the try-catch would catch the null pointer exception that would occur if activity became null. So that's really, really, really super paranoid, but probably not a bad idea in practice. And yes, Tomas, of course, it should be activity equals null. Let's see. There's a nice method, messenger m equals get parsable extra, blah, blah, blah. Oh, cool. Okay, so it looks like you can directly call get parsable extra in intent as opposed to saying get extras and then get. That sounds pretty helpful. Okay, what I'd like to do now, because we're kind of winding down here, is I would like to switch over and answer any questions people had asked on the discussion forum. Let me go ahead and do that. There we go. Let me find a browser. I had forgotten to do that last time, and this time I wanted to do that because I think it's good. We promised to answer people's questions even if they can't be here live. So let's go take a look and see which of these are still open issues. So print implementation. Aha. All right. Well, that's been deleted, so we will go ahead and zap that one. Let's see. Patterns. How does great question from Alan. How does a developer know which patterns to use when developing an application or service? Is it experience and previous usage of patterns that guide you? When reviewing code like your examples, how can we gain understanding by reading which patterns are used? So I guess that is a very interesting philosophy of education question, or epistemology of education question, Alan. A similar question might be, how do you know which Java programming language features to use when you write your code? Well, the obvious way that you learn how to know which Java programming language features to write your code is you take a tutorial or read a book or take a class or take a MOOC or look at a Palantir or whatever you do to learn, and you learn iteration, sequencing, branching, exception handling, threading, and so on and so forth. And when you first start, you probably only know a handful of constructs if you're doing Programming 101. And as you get more familiar, as you do examples, as you get practice, as you read code from other people, as you read books, as you take classes, you get to learn more about what's involved. And after you've been working with Java for 6 months or a year, you probably have a pretty good feel for a lot of the different parts of the programming language. Now, you may have still run across some new constructs. They keep adding stuff to Java. They may add lambdas. You may not be familiar with lambdas. You have to go learn lambdas. But you basically do it as you go, right? So that's how you learn how to program. So how do you think you learn how to understand patterns? Well, it's exactly the same process. You would start out by reading some books. You might read the Gang of Four book. You might take a look at the various videos that we have. For example, if you take a look here at my website, let's go to digital learning. Here's my digital learning website, and I've got links to my Coursera courses. The first Coursera course I taught last year has lots and lots and lots and lots of stuff on patterns, Gang of Four patterns, POSA patterns, patterns for concurrency, patterns for all kinds of things, lots of stuff there. I've also taught a course. I teach a course at Vanderbilt it's called CS251. I have a YouTube channel that has all the material from there as well, from that course. So if you go here, you can look at the playlist from CS251. If you read here, you'll see that there's, I don't know, about 10 lectures, each of which are about an hour or an hour and a half long on patterns. So that's a good place to learn. I have recorded a series of videos for Pearson's live lessons, which are on design patterns in Java. And so if you're interested in learning about design patterns in Java, you can go here. It's got about half the design patterns from the Gang of Four book. So, of course, the thing you do is you start by looking at those resources, reading books, watching videos, taking courses. But then even much, much more importantly than that, you've got to look at actual code. And that's why whenever I do my videos here in this class, I try my best to explain the patterns. The source code has lots of comments explaining this class plays the role of this, it plays this role in this pattern. This class plays a different role in a different pattern. This method plays a role in a pattern. So code that is written with patterns in mind makes it easy to map from the specifics of the example back to the genericity of the pattern. And so just like you learned how to program to learn programming language features, you do exactly the same thing with patterns, self-study, working in groups. Hopefully you've got people you work with who can mentor you, brown bag lunches, discussion groups, Wikipedia, there's lots and lots of ways. So it's definitely experience, and as you get smarter and better, you'll start to be more effective. It's not something that happens overnight, of course, but it definitely works just like you would learn, I think, pretty much anything else. Difference between command and command processor patterns. This is a great question. I hope my answer was helpful. So basically, there's command as a pattern, command processor as a pattern, and command revisited as a pattern. Command revisited really isn't the name of a pattern. It's just the name of a paper describing the command pattern and generalizing command and command processor. For my money, command is really about the object and trying to do closures or mini closures that can be passing around as parameters and then run in different contexts, like run in a menu, run in an undo, redo list, and so on. Command processor is about taking commands and then running them in different threads or different processes. So it's really focusing not just on the command, but also the context in the execution environment which the command runs. So I typically use command processor a lot more than I just use command by itself. And I give a nice example in my write-up about how the runnable interface in Java gives you a command-like abstraction, and then the Hammer framework and the intent service framework give you command processor environments. Hammer framework allowing you to take runnables and process them in other threads. The intent service framework allowing you to take intents, which are essentially like commands, sort of like commands, and then have them run in other contexts. An intent isn't quite as good an example as a command as a runnable is, because intents don't really have methods like run or execute. They're just basically data. The loader API, that's one thing we haven't talked about in this class. It's another way to do concurrency or asynchrony. I have a bunch of videos that I recorded for another course, and it talks about how loader works. So you might want to take a look at that for more information about loader. Let's see if there's other things here that we haven't already covered in detail. Let's see. Why are we targeting API 17? We're not really targeting API 17. That's just the one I have configured for my version of Eclipse, so I always know that that works. You ought to be able to use other things as well. I don't think people have reported a lot of problems with backward compatibility, but I just wanted to make sure I had one version that we had. People wanted to know how to learn from the example code. I strongly recommend watching the videos first and then looking at the code. You'll learn a lot faster. Override keyword. Basically, you can use override as a way to document that you're intending to override something from a base class, which can be used by tool checkers to make sure that you're actually overriding something and not providing the wrong parameters. Is synchronize still working fine when the method is not invoked in a Java thread? That's really a very language-specific question. I think there's a Stack Overflow article that talks about that. There was a question about MOOC research, the great topic. I gave a bunch of links to other papers and videos I produced talking about the work that we've been doing on MOOCs, looking at this whole fascinating genre more abstractly. So take a look at that if you have time. Might be kind of fun. And let's see. And then there's a bunch of, oh yeah, the virtual office hours should be interactive. That would be nice. There's not enough time in the day to do everything, but virtual office hours provides a way to answer the why questions that sometimes are missed during the videos. By the way, one of the things that's really helpful is people give feedback. The more specific the feedback, the better. I've actually been going back and updating scripts for my lectures and the slides for my lectures. So the next time I record these things, they'll address a lot of the questions that have come up repeatedly throughout the discussion forums. So we use virtual office hours as a way to answer those questions, and then I take that and I feed it back into the lecture material that'll get redone at some point down the road. All right, let's see. This is Sheila's question. Oh yeah, yeah. So Sheila, let's. I'll take that up with you offline. There's flaky stuff that happens, unfortunately, with. Unfortunately, there are flaky things that happen now and again with the Coursera uploading system, and it particularly seems to be flaky on the due date, because I suspect many thousands of people are all trying to upload things at the same time. I've reported this issue many, many times to Coursera, and they're trying to fix it, but I would not hold my breath. All right, let's see. Google I/O. Gary asked the question, what if there's no check for null activity? This was covered before. What is the background of the intent framework? Is it used Hammer framework in its realization? So yes, it does in fact use the Hammer framework in its realization. If you go and watch the Android Intent Service video, which occurred last week, it actually walks through all the code in the Intent Service, or at least all the interesting code in the Intent Service, and it shows exactly how it works. And lo and behold, it uses the Hammer framework. In particular, it basically has a way of sending and processing messages. So it uses the send message variant of the Hammer framework. So take a look at those videos and slides. It shows all that stuff. Does executor service shutdown stop the service? No, it does not stop the service. It stops the pool of threads that are running, but it doesn't stop the service. To stop the service, you'd have to call stop self or stop service, which would stop the service. Let's see, another question from Chen. Multiple threads, Hammer, looper, handler, async task, communication between activity and service, started service, intent, messenger. Okay, let's see. So this is, I think, Chen, if I understand your question correctly, I think what you're asking is, what are the various ways in Android of doing things concurrently, right? And we cover these things over the past several weeks, but I'll recap them briefly. So the Hammer framework, which has two variants, the runnable posting mechanism and the message sending mechanism, that's the sort of common way of passing messages and runnables back and forth, either commands or messages, using either the command processor pattern or the active object pattern, a variant of the active object pattern. Underneath the hood, they use the same basic mechanisms, using message queues and loopers and all that kind of good stuff. So that's one way of doing things. It's a very simple way of doing things, but it also requires you to understand the patterns of programming, because it's basically a bunch of building block pieces that are loosely connected. So you have to know how to connect them through knowledge of the patterns. But it's very simple. The async task framework is more cohesive. It's more coupled. It's more powerful in some ways, but at the same time, it's also doing a lot more for you. So there's some overhead underneath the hood in the async task framework that isn't there in the Hammer framework. I like async tasks a lot, though. They're really easy to use. You just have to basically inherit from async task, and depending on whether you want to use a pool of threads or not, do a couple other tweaks, but they're really, really, really simple to use. And once you understand the patterns that they implement, they're really, really easy to make sense out of. It's basically a multi-threaded template method is essentially what the thread pool is, combined with strategy if you want to use the strategy part. And there are videos, all the videos that you can take a look at from week 3 and week 4 talk about these frameworks and compare and contrast them. Now, when you start, and Hammer framework and async task are really used when you're talking within an activity. So they're really used for intra-activity concurrency. When you start to have communication that spans boundaries between activities and services, especially when those services run in separate processes, you got to use something more than just the Hammer framework and the async task framework. So messengers are essentially an extension, in my mind, of the Hammer framework that allows you to use the active object pattern in a way that spans multiple activity and service contexts, using that word loosely, environments, let's call it that. And you could also have the services run in a separate process, which gives you even more deployment configuration flexibility. So in my mind, messengers and the use of runnables, messengers and the use of handlers, is basically the Hammer framework stretched out to go between activities and services and across processes. And of course, you can also use this for service-to-service communication if you so desire. The common case is typically activity-to-service communication. And the patterns that those guys do are basically the it's an active object pattern variant. Now the intent service is kind of a command pattern variant, and that is more stylized. You could combine it with messengers, as we do in the programming assignment that was put out for week 6, or not. But that basically is the command processor pattern, and you send an intent over, and it's processed in the background in a thread of control. Now, if you don't, and you can spawn pools of threads if you so choose, using the executor service or some other thread of pool of threads, and you could have your services be multi-threaded. And there's a whole pile of examples that I have that I show how to do that, including things like the unique ID generator application and the download application and all those other stuff. Then there's also aidl, and aidl is basically a combination of things. It's a type-safe way of being able to make method calls through stubs, which are essentially proxies, and it uses the proxy and broker pattern in order to be able to do communication, typed communication, between activities and services, or between services and services. And so it's a more powerful mechanism. It's really intended for use when you have an activity or some other client that wants to engage in a long-running conversation with another service, and it wants to be able to do that in a way that pushes the type issues out of the hands of the application developer and into the infrastructure, either into the aidl compiler or into the parsable interfaces that are created by the aidl, by people who use aidl. So that's kind of a summary of the main mechanisms. There are other mechanisms you can use in Android for communication, things like broadcast receivers, things like pending intents. I don't cover them in this MOOC, but if you take a look at the videos for my CS282 course, which are up on YouTube, there's a lot of discussion there of pending intents and broadcast receivers. So if you're curious, you can take a look there, and it goes back to the more. Will there be a virtual office hour held by Professor White? Yes, probably when we come to the next week's programming assignment, which is due next week, which is the one on the I Remember application. I am hoping he'll be able to join us and overview kind of what he's looking for and how to evaluate that one. For best start reading about patterns, do I start with the Gang of Four book or the POSA books? You actually, if you really want to get an introductory overview to patterns, you might want to read the Head First series of books on patterns. I think there's a book called Head First Patterns or something like that. And people who are really looking for an introduction to patterns often say that they like that the best because it's a very gentle introduction. The Gang of Four books, the POSA books, probably assume people who read them are pretty familiar with object-oriented programming and C++ or Java or Smalltalk or whatever. So they may or may not be the best books to start with if you're absolutely fresh and brand new. I strongly recommend taking a look at the online resources, watching the videos that I showed you before. That's some good places to look for more information about some of the different information on patterns. So, take a look at code, watch the videos, read the books, and ask questions on the discussion forums, and that should hopefully help you. Okay, well, it looks like we're winding down. So what I will do is, as usual, is I will go ahead and post-process the video, get rid of the creepy-looking green background and replace it with much more soothing blue background. And I'll probably edit things a little bit so it'll start off by the discussions where we're talking about the actual programming shells and looking at the solutions there. We'll probably start with that. But if there's any other questions, we have another couple seconds, and I'd be happy to answer any questions that you might have. Okay, so it looks like we're all done. So thanks very much for joining, and I will look forward to talking to you next week.